Okay, so you have your tests back. On your tests, I allow something called corrections. If my pen will work here. And what corrections are is you can redo the problems you got wrong. Now, when you redo the incorrect problems, you can't just put an answer down. You do have to show your work. So you do kind of have to go step by step and show me what you did. I give you about a week or so to get corrections done, so it's not a rush. Take your time. The biggest thing is make sure you have them right. You can work with each other. You can come ask me. You can go to the Success Center, the Academic Support Center, and get help from them if you want to. Just make sure you have them right when you turn them back in. I do the corrections for two reasons. One is to obviously allow you to get some points back. But the main reason is I want to make sure everybody has the correct answer and the correct process down. I think the ones you get wrong on the test are your biggest learning opportunities because you're motivated to know how to do them because you now know for sure that you have something that's not quite fitting with them. When you do those, you get up to half your points. If you get them all correct, you get half your points back. So for instance, let's say that you had a 72% on the test. After corrections, that 72% turns into an 86%. So that 72% is a D minus, 86% is actually a B minus that turns into. So it's definitely worth your time to do the corrections. Like I said, if you have problems that you're not sure of, work with other students, come ask me, make sure you know for certain that it is correct before you turn it back in. Now, with that said, I'm not going to answer any questions on the test today because I do want you to take them home and try to figure them out on your own before I answer any questions on them. But I will, Wednesday or Thursday, take some time to answer any questions you might have that you can't figure out. But like I said, feel free to work with each other and ask each other as well to get those done. Okay, so today we're moving on into Unit 2. Unit 2 involves a couple of things. We're going to deal with more algebra and, of course, applications of algebra. Using variables, solving equations, problem solving. But then Unit 2 also contains fractions. So in the next couple of classes, we will start talking about fractions and how they fit together. Today, we're going to be working with algebra and formulas. When we do problem solving in algebra, word problems, there are certain formulas that we're given that we've seen a little bit already, and we're going to see more, that we're going to just plug numbers into. One of them we looked at was gross profit. Gross profit is equal to that total revenue minus costs. Now, for gross profit, we usually don't figure in, like electricity, the overhead, and stuff like that, and labor. We just figure what does it cost to purchase the item and what do we sell it for. So we've had some word problems already that involve this. We have to clarify in some cases revenue isn't necessarily just for a single item. It can be total revenue, where it could be the price times the number sold for selling multiple items. And costs can be the cost times the number sold. if we're selling multiple items. Now, you might think, well, when we're buying them, aren't we looking at the number bought? Yes, we are, but when we're talking about gross profit, we're only looking at the cost for the ones that were sold. So we're only figuring out how much we paid for the ones that we actually sold. The ones that are still sitting on the shelf, we've purchased them, but we're not figuring them into that equation yet. So let's take a look at an example here where Frankie sells candles for $8 and buys them for $5. How many candles does Frankie sell to earn a gross profit of $8,727? So here again, we've got this formula up above here. Gross profit equals that total revenue minus the total cost. Our gross profit in this case is the $8,727. That's got to equal our total revenue. Now this is multiple items, so total revenue is going to be the price that we're selling them for, $8 times the number sold. We're going to let X be the number sold. So $8 times X is the money that we have coming in from selling those candles. And we're going to subtract what we paid for those candles. That would be the cost of $5 times, well, we're still going to use X as the number because, again, we're only concerned about the cost, what we paid for the ones that we've sold. So now what do we do to solve this equation? Careful, there's one step we got to do first. Remember, there's 3 steps here. Step 1 is to combine or simplify on each side. That's the one we have to do first here. Step 2 is make sure the variable is on one side. And the final step 3 is to actually solve it. Here we have a step 1 that we can do, which is, combine the 8x and the minus 5x to get 3x, positive 3x. There we go. Now we can solve it by dividing by 3. So we get 2909. X equals 2,909 candles. Now this is where we would go back and make sure we answered the question. The question is, how many candles Frankie sell? And X represents the number sold, so that 2,909 is the answer we are looking for. There are some more complex formulas that we can run into. One of those formulas is for mixtures, investments. We can use it in chemistry for mixtures as well, for the concentration of the solution. You know, 2 different solutions when we mix them together to get the final concentration. But for example here, let's say, well, let's do the formula first. For investments, we have the rate of the first one times the amount invested. So we're going to put rate 1 times amount 1 plus rate 2 times amount 2 equals the total rate times the total amount. Now, there is an implication within here, by the way. Even though this total formula is true, there's also an implied thing that the amount invested in investment 1 plus the amount invested in investment 2 equals the total amount invested as well. So anyway, let's say that we have Pat invests $3,000 at 8% and $5,000 at, let's go 4%. What percent total return did Pat earn? So what we have here, we have rate 1 and amount 1. Well, that's the 8% and the $3,000. Now the 8% is going to get written as 0.08 times 3,000. I put it in parentheses just because putting times there would be kind of confusing with the decimal. Plus rate 2 and amount 2. Well, that is our $5,000 and 4%. So 4% is 0.04. $5,000 is the amount. Equals, what is the total percent return? So that rate, that total rate is what we're looking for here. What goes in is the total amount. $8,000. We just have to add this plus that equals that. So now to solve this equation. Remember, step 1 is to always combine what we can on each side. So we're going to combine 0.08 times 3,000, which is 240 bucks. 0.04 times 5,000 is $200. Equals R times 8,000. I'm actually going to write that as 8,000 R. I can still combine here, by the way, the 240 and 200 is 440 equals the 8,000 R. So now the second step is the variable on one side. Yes, it is. So then just we'll go ahead and solve it by dividing by 8,000. So we get 0.055 equals R. What that is telling us is the return here, move that decimal point back, is 5.5%. What do you think? Not horrible? Why don't you guys try one? So Sam invests $4,000 at 6% and $2,000 at 9%. Find the total return. I'll give you a couple minutes to work. Okay, so to set this up, we have investment 1. We got the rate of 6%, 0.06, times the amount of $4,000, plus the second one, 9% is 0.09, times $2,000 equals whatever that final rate is going to be times the total is 6,000. So we have 0.06 times 4,000, which is 240, plus 0.09 times 2,000, which is 180, equals 6,000, zero in there. We're still combining over here. 240 and 180 combined to make 420 equals $6,000. And then divide by the 6,000. 0.07 equals R. So 7% is the return. Well, let's check something out that's a little bit more difficult. Let's say Sam invests $12,000. Some at 5% and some at 9%. If the total return is 8%, how much did Sam put in each investment? So here again, we have two investments. I'm going to write it out here. We've got a 5% and a 9%, and we're combining to make an 8% investment, right? So we know the rates. We've got the 5% or 0.05, 9%, 0.09, and so on. What we're looking for is the amounts. Well, we know that the total amount invested is how much? $12,000. We don't know how much was put into either of the other investments. So we just pick one. I'm going to let the amount invested at 9% be X. If I know I put X into 9%, how much did I put into 5%? Well, let's look at it this way. If I told you I invested $5,000 at the 9%, how much then went at 5%? 7. How'd you get the 7? 12,000 minus 5,000. We just took the total amount minus whatever was in the 9%, that had to be in the 5%. Well, that's just 12,000 minus X. So now we're going to write this out. The interest or the return from investment 1 is 5% or 0.05 times the amount is 12,000 minus X plus the amount from the second investment is 9% or 0.09 times X equals 8% or 0.08 times 12,000. So now again, we simplify or combine whatever we can on each side of the equation. On the left side, I have parentheses here. Can I do anything inside of them? No. So is there anything that needs to be done to them? Yeah, multiplied by the 0.05. 0.05 times 12,000 is 600. 0.05 times negative X is negative 0.05X. And we still got the plus 0.09X here. Now, before I move over to the right side, there's still more I can combine here. Can I combine anything with the 600? No. So the 600 stays. But I do have the negative 0.05x and the positive 0.09x, which combines to make positive 0.04x. Now on the right side, there's something I can combine as well. 0.08 times 12,000 is 960. Now what? Is there a variable on both sides? No. So I can solve. To solve it, where would I start? Subtract 600. So I have 0.04x equals 360. And then divide by 0.04. So x equals 9,000. Now we have to go back and make sure we answer the question. You know, x is 9,000. Well, x was the amount that was put in at 9%. So we know that $9,000 was put in at 9%. 5% is 12,000 minus x. So 12,000 minus 9,000 is $3,000 at the 5%. Any questions? Yet another variation. Let's say Stacy invests let's keep this simple for me here. $6,000 at 11%. How much did Stacy invest at 6% if the total return was 9%? Same type of problem, a little bit different variation again. So what are the two things that we are combining? What are the 2% that we are starting out with here? We have 11% and 6% are the ones that we are putting investments in. We are trying to mix those to create a total of 9%. Do we know the amounts of any of those? $6,000 goes with 11%. We're asked to find how much was put in the 6%, right? To get a total investment of 9%. Well, then how much is really going to be their total? Remember we said the total amount, the amounts have to add up to the total as well. So 6,000 plus X is just 6,000 plus X. So now we can write our equation here. 11%, 0.11 times 6,000 plus 6%, 0.06 times X equals 9%, 0.09 times 6,000 plus X. Now we can simplify simplify whatever we can on each side. On the left side here, we've got 0.11 times 6,000, that's 660. Plus 0.06x is 0.06x. Is there anything more we can combine on the left side? No, so let's go to the right side. What can we combine there? Well, we have parentheses here. Anything we can do inside the parentheses? Well, 6,000 plus x, remember, have different names. This is ones, that's an x. So we can't combine them in there, but we can multiply the whole thing by the 0.09. So 0.09 times 6,000 is 540. 0.09 times x is 0.09x. Now remember, the second step when solving any of these equations, we've simplified everything on both sides. The second step is to see if x is on one side. Is x on one side of the equation? Well, right now it's on both sides, isn't it? So we have to fix that. Which one are we going to get rid of? 0.06 is the smaller one. It is positive, so we get rid of it by subtracting. Leaves us with just 660 over here. We have to take 0.06x from the other side. We're going to take it from the 0.09x. So we've got the 540 still here. 0.09 minus 0.06 is 0.03x. And then subtract the 540. That gives 120 equals 0.03x. And then divide by 0.03. 120 divided by 0.03 is 4,000 equals x. Now again, let's go up and see what x is and make sure that that answers our question. X is the amount of 6%. That's $4,000 at 6%. We're asked, how much did Stacy invest at 6%? So that is answering our question. So we're all done. Any questions there? Okay. Well, let's move on to some different types of problems. Let's look at something that you maybe don't know as much about. We're going to look at geometry. Now, just like algebra that we've been seeing so far, at least with our arithmetic, that everything builds up from a couple of basic concepts, the same thing happens in geometry. It builds from a couple of basic concepts. First of all, the most basic item or structure in geometry is this thing right there. That is just a point. And a point does nothing more than mark a location. It has 0 dimensions. Because if you were on that point, you would have no movement, no place you could move, no directions where you could measure any lengths. Well, the second part of geometry is movement. I can take that point and I can move it in a single direction. And if you think of it as like dragging the end of a stick across the sand, it's going to trace out that shape. Pretend it's straight. And when we move in a direction, it's always considered to be a straight direction. That is what creates what we call a line segment. A true line goes on forever in both directions. A line segment is a piece of that line. Now in practice, whenever we say line, we usually are talking about a line segment because the line itself is not that useful because it goes on forever in both directions. The length of this line segment is equal to the distance moved. And this, by the way, now has one dimension. If you were on there, you could move in one direction. A lot of people are like, well, why don't you can actually move left and right? Why can't you say you're moving in two directions? It's technically only one direction. You pick one of them to be positive and the other going backwards to be negative. So you're either going positive or negative in the same direction. But the point only moved one time to make that. Now from there, there's a couple of different directions I can go, a couple of different things I can do with it. The first thing is I can take that line segment and I can move it again in the whole segment in a second direction. But this second direction is perpendicular to the first. Now, perpendicular just means at a right angle. It's a little bit stronger than, oh, come on now. There we go. A little bit stronger than just right angle because it's perpendicular in every measurable direction. Now, if we go back to think of that stick tracing a line in the sand, if we think of this again as being a stick laying in the sand as we pull it across, it actually is going to trace out a rectangle. The size of this rectangle, the area of the rectangle depends on the original length and then the new distance moved. That new distance moved, we're often going to label as a width. So we still have that original length of the line segment, and we now have this width, or this new distance that's been moved to create an area. This is now two-dimensional because it's been created by moving in two different directions. We're going to talk more about areas coming up in a little bit. For now, I want to go back to that point and that movement. So I take that point. Now we said we could move it and the distance we traveled was equal to the length of a line segment. Well, for right now, we're going to ignore that distance because we're going to take that point and we're going to go in a single direction and we're going to assume we keep going forever. That is called a ray. An array is totally defined by two things. One is that starting point. The second is the direction. And we measure the direction off of a grid. The grid is centered on that starting point. Think of it like a compass rose. This is the east, north, west, and south directions. The east direction, this comes from navigation. If you're dealing with navigation, the east direction is considered 0 degrees. North is considered 90 degrees. West is 180 degrees, and so on. So this right here, let's say that is from the east direction. Let's say that is 14 degrees. So the direction of this would be 14 degrees. An angle is created. Let's say we have this ray here still that is a 14-degree direction. We create that angle by going back to that original starting point and moving in a different direction, creating a second ray and, of course, a second direction. And let's say this new direction here is 48 degrees. The size of the angle is equal in the difference in direction of the rays. So this size of the angle right here is just going to be 48 minus 14, or 34 degrees. Now that is the old definition, the original definition of an angle. It's just that, difference in direction. It used to be very common for people to be familiar with navigational directioning like this. Nowadays, it's not so much. People aren't necessarily familiar with that at all. So they've come up with an alternative definition of an angle that goes off of this. If I start out moving in a single direction and I turn all the way around, so I'm back to moving in that same direction again, how many degrees did I turn? One complete rotation is 360 degrees. Well, let's go back. Let's say I start out moving in a certain direction and I turn. And I turn so that I am heading back exactly in the opposite direction. How many degrees did I turn? 180 degrees. How did we get that? Yeah, 360 divided by 2, or 1/2 of 360. It's half of a full turn. If I start out moving in a direction and I turn so that I'm going exactly off to the side, what we call a square corner, how many degrees is that? 90. Again, how do we find that? Well, it's 1/4 of a full turn, or 360 divided by 4. So our modern definition of an angle is the fraction of a full turn. If I say an angle, let me give you an angle here. If I say that this angle is 82 degrees, what that is saying is that this is 82 3/60ths of a full turn. So now with that in mind, there are some relationships we want to look at here. Our first relationship happens when we do this. So we create that first ray. We create that second ray to create an angle. Let's say that this angle here, 38 degrees. But I'm going to go back to that same starting point a third time and create a third ray. This ray, let's say, is 19 degrees. I now have 3 rays and I have 2 angles. And these 2 angles share a vertex. What's that vertex? Well, that's just the common starting point of the rays. And they share a side. This side right here is shared by both angles. This is referred to as adjacent angles. Now, it is very important that both of those conditions are met. They share a vertex and a side, because you can see angles that are like this. They share a side here, but they do not share a vertex. Those are not adjacent. The nice thing about adjacent angles is they are additive. Now, additive implies that it's basically saying they can be added, and being added also implies they can be subtracted. So if I look at this situation I drew over here with these two adjacent angles, I can look at this big angle here and I can find it by just adding the 19 degrees and the 38 degrees to get 57 degrees. That total angle is 57 degrees. Or I might have a situation like this where I tell you that this total angle is 44 degrees. This little angle here is 21 degrees. And to ask, what's this angle? Well, if the angles can be added, they can also be subtracted. If I call that x, I can actually think of it as x plus 21 equals 44. To find x, I would subtract 21. X is 23 degrees. Any questions so far? So these adjacent angles have some special relationships. We might have angles that look like this. If I tell you that this one here is 61 degrees, what's this angle here have to be? Well, I know that since this is a straight line, that is 180, right? So to find the other angle, I subtract 61 from 180, this is 119 degrees here. Two angles that add up to 180 degrees are called supplementary or supplements. In this case, they are adjacent angles. They don't have to be adjacent to be supplementary, but in practice, that's when you're going to use them the most is when you have adjacent angles that add up to a straight line. Whenever you put that little box down in the corner of an angle, that box is a square. It is saying that's a square corner or a 90-degree corner. If I tell you that this angle here is 19 degrees, what's this one here have to be? 90 minus 19, very good, which is 71 degrees. When we have two angles that have to add up to a square corner or add up to 90 degrees, those are complementary. Now, if you're anything like I was when I first learned these, I could remember the two words really well, but I had a hard time remembering which one was which, supplementary or complementary. And the way I learned it was this way. 90 degrees is a right angle. You get complements when you're right. There is a third relationship I want to look at that kind of involves these adjacent angles. I mean, there's adjacent angles in it, but it's really more about intersecting lines. When I have two lines that intersect like this, there are actually four sets of adjacent angles that are formed. If I tell you that this angle here is 40 degrees, and I ask for this angle here, what I'm looking at is this set of adjacent angles, this one here and this one here. Those two angles are adjacent. They share a vertex, they share a common side, and they also combine to form a straight line. So not only are those two angles adjacent, they are supplementary. which means I can find this angle up here by doing what? (180 minus 40). Good, that's 140 degrees. Now, if I wanted to look at this angle here, well, now I can look at, I've got this angle and this angle that are also adjacent angles. They share a vertex and a side here. These two also add up to a straight line, which means those two are supplementary as well. So what does the total have to be for that? Or what does this one end up having to be? Yeah, 180 minus 140, that's 40 degrees for that angle. If I wanted to find this one down here, I could go about it two ways. I could use this angle here along with this one. Those two are going to be adjacent. Or I could use this one here along with that one I'm looking for. Either way, they add up to a straight line again, which means it's 180 minus, well, both of those are 40, which is 140 degrees. We notice here that there are only two angles formed. There are the two 40-degree angles and the two 140-degree angles. Only two different measurements formed. The angles that are the same here, that are across from each other, those are called vertical angles. They are formed by intersecting lines. They're the opposite corners of intersecting lines. So, there's four corners where these lines intersect. These two are the opposite corners. They're equal. These two are opposite corners. Those two are equal. They are supplementary to the same angle. If this were a formal geometry class, we'd talk about this a lot more, being supplementary to the same angle. This right here, this 140, is supplementary to this 40. This 140 is also supplementary to that 40. So then therefore they must be equal. If they're supplementary to the same angle, they have to be equal. Okay, I went a couple minutes late in our first hour here. It is time for our break. It's 9:22. Let's come back at 9:32 and we'll keep going with it. Okay, so how does this tie into what we were talking about at the beginning of that first hour with problem solving and solving equations? Well, we can have pictures like this, where we are given that this here might be 2x plus 7, and this over here might be 3x plus 23, and be asked to find each angle. Excuse me. Well, in that case where we're asked to find each angle, we look for the relationship. There are three possible relationships like we've discussed before. There can be a relationship where either A has to equal B, one amount equals the second amount. There can be a relationship where one amount plus another amount equals a total. Or the difference between two amounts equals a set difference. One amount minus the other equals a set difference. Now in this case, what is the relationship between those two angles? This here, of course, is a straight line, which means those two angles add to 180. They're supplementary. So 2x plus 7 plus 3x plus 23 add up to 180. So now again, we're solving this equation. Is there anything we can combine on each side? Two x and 3x make 5x. Anything else? 7 and 23 make 30. No more to combine. Is x on one side of the equation? Yes, the variable's on only one side. So we can go ahead and solve. How would we solve it? We subtract 30. 30 is gone. We have 5x equals 150. And then divide by 5. X equals 30. Now again, as always, we need to go back and make sure we answered the question. The question here was find each angle. Well, 30 is x, but that's not either of the angles. So I put 30 in for x in this first one. 3x becomes 3 times 30 plus 23. 3 times 30 is 90, plus 23 is 113 degrees. Down here, 2x becomes 2 times 30 plus 7. 2 times 30 is 60, plus 7 is 67 degrees. Do those two add up to 180? They do. So that is, those look like those should be the correct answers. Adds up to 180. What if I want to find, or what if I tell you here that this angle is 22 degrees? I want to find the other two angles. What do I know here? Well, these are adjacent angles, right? This one plus this one adds up to the big one, doesn't it? So 2x plus 7 plus 22 has to add up to 4x minus 9. Is there anything we can combine on each side? Yeah, we got the 7 and 22 here. So this is 2x. 7 plus 22 is 29. Does the variable appear on only one side? No, it's on both sides, which means we have to get rid of one of them, which will be the 2x. We're going to subtract 2x. So here we've got 29 equals 4 minus 2 is 2x minus 9. And then we solve. We add 9. 38 equals 2x. And finally, divide by 2. 19 equals x. Now again, we have to make sure we answer the question. I didn't actually write it down, but I asked you to find those two angles. If x is 19, this one becomes 4x, becomes 4 times 19, minus 9. 4 times 19 is 76, minus 9 is 67 degrees. So that whole big angle is 67 degrees. This one here, 2x plus 7, 2x becomes 2 times 19, and then the plus 7. 2 times 19 is 38, plus 7 is 45 degrees. So that angle is 45 degrees. What's the relationship between these two angles? They should be the same. 5x minus 31 has to be equal to the 2x plus 5. So again, if I'm asked to find each angle, we're going to start out, is there anything to combine on each side? No, each side is as simple as it can be. Is the variable on only one side? No, it's on both sides. So here we have to do something with it. We're going to subtract the 2x. So we've got 3x minus 31 equals 5. And then add 31 to both sides. 3x equals 36. And then divide by 3. X equals 12. So now again, we have to go back and answer the question. I didn't write it down, but it was find each angle. So if x is 12, 5x becomes 5 times 12 minus 31. 5 times 12 is 60. Minus 31 is 29 degrees. Now we probably could stop there, but let's do the other one just to double check. These better be the same, right? 2x becomes 2 times 12 plus 5. 2x is 24. Plus 5 is 29 degrees. They're the same. Which kind of checks out because they needed to be equal. And you know, find each angle. I'll give you a couple minutes. So what's the relationship between these two angles? They add to 90 degrees. 12x plus 3 plus 5x plus 2 has to add to 90. So anything to combine on each side? 12x and 5x make 17x. And then 3 and 2 make plus 5. I don't know why I put 3 over there. That should be 90, right? Some days the little hamster just won't do it. Now the variable is on only one side, so we go ahead and start solving. What do we have to do? Subtract 5. 17x equals 85, and then divide by 17. X equals 5. So now we have to go back and answer the questions. Find, not really a question, a command. Find each angle. So 12x becomes 12 times 5, and then we still have plus 3. 12 times 5 is 60. Plus 3 is 63 degrees. Down here, same thing. 5x becomes 5 times 5, and then the plus 2. 5 times 5 is 25. Plus the 2 is 27, so 27 degrees. Those add up to 90 degrees. How many of you had that right? Good. Well, let's try one more. Try to find those two angles. I'll give you a couple minutes. So the relationship between these two is they have to be equal, yes. 7x minus 14 has to equal 5x plus 11. So now to solve, is there anything to combine on each side? No. Variable on only one side? No, so we have to get it on one side. So we're going to subtract the 5x. So 2x minus 14 equals 11. I screwed that up, didn't I? Oh well, we'll make it work. So then, add 14. So 2x equals 25. We divide by 2, x is 12.5. Wasn't trying to get that one to come out to a decimal, but it did. So then we do have to answer our questions. 7x becomes 7 times 12.5 minus 14. 7 times 12.5 is 87.5 minus 14 would be, what's that? 73.5. Thank you. Here, 5 times 12.5 plus 11. 5 times 12.5 is 62.5 plus 11, 73.5. So that example may not have been the best as far as we haven't worked with decimals yet and definitely not drawn to scale. But you guys get the picture. Other formulas that we have worked with, perimeters. We've talked about this one quite a bit. For a rectangle, if this is the length, this is the width, the perimeter is 2 times the length plus 2 times the width. If I tell you a rectangle with perimeter of 80 has a length that is 4 more than the width. Find the length and width. So here we know this formula here. We know the perimeter, but we're looking for both the length and the width. So we have to get it down to a single variable here. And usually what we look for is that relationship between them. We say the length is 4 more than the width. So if I let W be the width, if I know the width first, I can find the length from that by doing W plus 4. And then those are the things I put into the formula. So the perimeter is 80. I put 80 in for P. Equals 2 times the length. Well, length is W plus 4. So it's 2 times W plus 4. Plus 2 times the width, which is just 2W. And now we solve the equation from there. We do have parentheses. Oops, to combine on the right side. So we do the 2 times W is 2W. 2 times 4 is 8. Now we still have 2W and 2W to combine. Makes 4W plus 8. On the left side, there's nothing to do with the 80. It's just 80. We now solve by subtracting 8. 72 equals 4W. And then 18 equals W. So if 18 is W, we need to go back and find the width is 18, the length is 18 plus 4, or 22. Look familiar? We talked earlier today about the area of a rectangle, and that the area depended on the length of that original segment and the distance it moved, or the width. The formula becomes the area equals length times width. So from that formula, a rectangle with area of 124 has a width of 4. Find the length. I'm going to give you guys a minute in your notes to see if you can find that. So we have that formula, area equals length times width. We have the area of 124. We're looking for the length. The width is 4. So to solve this, we're simply going to divide by 4. 124 divided by 4 is 31. That's our length. Now, I didn't put any units on that, which I probably should have. So now, as we keep working with these, we will get some basic areas, or a little bit more than the basic areas involved. We may run into some problems that look like this. And they want you to find an area. Well, let's give you some dimensions here first. Something like that. But one of the first things we have to be able to do is find missing dimensions. So if I look at a little bit simpler example of finding missing dimensions, it might look something like this. If I tell you that this here is 18 feet and this is 26 feet, if I give you that this piece is 17 feet, what's this piece here? 9 feet. How do we get that? Okay, since this is a rectangle, we know that opposite side, well, we can base it off a rectangle, I should say. If I fill in this corner here, I know that as a rectangle, the opposite sides would have to be equal. This side and this side would have to be equal. So in other words, the total distance from here to here has to be the same whether we go across the top or the bottom. Well, this is one big piece, that's 26 feet. Up here, it's split into two pieces, 17 and x. So we know that 17 plus x has to equal 26. We solve that by subtracting the 17. That gave us x equals 9, so that piece is 9 feet. You know, we see these equations, and we think, well, how does that apply to everyday life? I'm never going to use algebra, I'm never going to solve an equation in everyday life. And there's some truth to that. Here, you probably didn't write an equation, you just did 26 minus 17. But the thought process you are using is this one right here. You know these two pieces have to add up to 26, so then you work backwards by subtracting the 17. So on this one here, we need to find some missing sides. Now this is a lot more complex. To find this missing side, I know that the distance from here to here is the same as the distance from here to here. Does that make sense? There to there. So what I'm going to do is I'm going to look at, I'm going to call that distance x. Whatever that distance is has to be the same as the distance from here to here if I go around the other side. So from here to here is 10 feet. That means this is at 10 feet from our starting side over here. Does this here change that distance at all? No, that's perpendicular. It doesn't change that distance. Here we go 5 more feet. So 10 plus 5 is 15 feet. So at this point here, we're 15 feet from our starting side. Does this 6 change it? No, that's perpendicular again. The 15 changes it though. So once we get here, we're at 30 feet. Good. Does this change it? No, so we're still at 30 feet. Here we're going back 8, which means this is at 30 minus 8 is 22. So this side here is 22 feet. Now, going the other way, finding this distance. We know that distance has to be the same as this distance. So I'll call this y. So over here, starting here at 0, this is at 5 feet. Does this 8 change it? No. We come here. This 6, though, puts us at 11. Does this 15 change it? No. So we're still at 11. We go back 6, so we're now back to 5. Moving over here doesn't change it. This is at 5. We go up 10, so we're at 15. 5 plus 10 is 15. So this is 15 here. So y is 15 feet. So now we have all those missing dimensions. And that's probably the most difficult skill in all of this, is finding those missing dimensions. Now I'm just going to cut this up into rectangles. Now there's probably other ways you could cut it up that would work. That's just how I chose to do it. This rectangle here is 15 by 10, which is 15 times 10 is 150. Feet times feet, of course, is square feet. Now this one we actually did, it was 5, this was 5 feet here. 5 by 5, of course, is 25. This one here, we didn't get this distance here, did we? This is 15 and this is 8. This distance has to be 7. So that one is going to be 5 feet by 7 feet, or 35 square feet. Then this one down here is 6 feet by 15 feet, or 90 square feet. So that total area is found by just adding them up. 150 square feet plus 25 square feet plus 35 square feet plus 90 square feet comes out to be, what, 300 square feet, isn't it? Does that make sense? So we take one of those rectangles. This is still a rectangle, even though it looks slanted. We're just looking at it from above and kind of at an angle. If we take that rectangle, that area, that 2 dimensions, and we continue what we were doing before by pulling it in a third direction perpendicular to those first 2. Of course, we create a box. The volume of that, of course, that's now 3 dimensions because we've moved in a third direction. The volume depends on the original area of that rectangle, which was the length, times the width, and that new distance moved, which we're going to refer to as the height. So find the height of a 10-inch by 8-inch box. With volume of 108 cubic inches. So we're using this formula right up here. We know the volume is 108. We know the length is 10 and the width is 8. We're looking for the height. I did that way off. Let me just correct this to make this a little better. I'm going to change that from 108 to 240 cubic inches. Make life a little easier on us. So now, is there anything I can combine on either side of this equation? Well, yeah, I've got 10 times 8 here, which is 80 times h. So 240 equals 80 times h. And I have to divide by 80. So 3 equals h. That box is 3 inches tall. So since there was a test last class and there was no homework due for today, there is no new quiz, but there is new homework that will be due for Wednesday. Also remember, test corrections. Let's try to have those by next week, Thursday. What is that, February 22nd? And also a note, this Thursday, which I believe is February 15th. Yeah, that looks right. Is career day. I don't know how many of you have other classes. There should be no daytime classes meeting during the day, but some of your other classes may require you to come in and help out with. There's going to be high school students here. So they may ask you to come in. What's that? Okay. So, but some of your other classes may ask you to be here to help out with tours and stuff like that. Since I don't have a program I'm dealing with, I don't have that. I actually help out with others. So this class will not meet on Thursday, just so you know ahead of time. So you will have that homework and the test corrections to work on for Wednesday. Any questions? Okay.